So today we are going to look about trigonometry. And under trigonometry, we are going to look several subtopics. First of it being degree. Now here we will be in a position to know what do degree mean. We can be able to differentiate between degrees and radians. So we're in position to differentiate degree and radians. Now still we'll be in a position to know how we can convert a given degree. Know how to convert degree to radians and vice versa. Vice versa means that we can still know how to convert radians to degrees, and by that we can simply look about degree. So we can come a circle. We can look at least a circle. We all know that a circle adds up to 180 degrees. Now if we divide this in 4 portions like this, now here is 0 degrees, this is 90 degrees, and this is 180 degrees, this is 270 degrees, and this is 360 degrees. Since we started this way, we went this and we came back at the same point. It means that we went around 360 degrees. And here we have to note that degree are used primarily to describe the size of an angle. Given like a certain angle like this, you can be in a position to know, so that you can calculate the degree here and use the concept that we are going to see soon. Now still, the real mathematicians is the radians. And since most computations are done in radians, no, that is the reason in this unit you have to have this knowledge of how you can convert degrees into radians. Now we can be in a position to look radians. So one revolution is measured in radians as, now one revolution is equals to 2 pi. This is one revolution, and here we know that one revolution takes 360 degrees. How can we convert this? It is easy, since 360, we can come 360 degrees is equivalent to 2 pi. What about 1 degree? We can cross multiply here. So this will be 2 pi over 360 degrees is equal to 1 degree. Now this is how we can make it to convert, since by this we can multiply by this 1 by this 180. And we come here and we conclude that 1 degree is equivalent to, that is pi over 180 radians. That is simple how we can be in a position to convert radians. So we just note that since 1 revolution is given as 2 pi r, what about 1? You cross multiply, and then you take 2 pi r, 2 pi divided by 360, so that you can get 1 degree is equal to how many radians. Now we can come here and see that 180 degrees, still we can come and say 180 over pi is equivalent to 1 degree. So example, we can look at an example here. This is 2 pi. An example here says that convert 60 degrees into radians. Solution, you can come and say 360 degrees is equivalent to 2 pi radians. What about 1 degree? Okay, we are, in this case we are given 60, so it is 60 degrees. So we can cross multiply. It is 60 degrees times 2 pi radians over 360 degrees. Degree and degree will cancel, so we will have 120 degree over 360. Now here, by this, we can divide through by, we can use calculator to divide it. So it will be 120 divided by 3, 60. We'll get 1 over 3 pi. So this will be 1 over 3 pi radians. So we can look another example here. An example says that convert 45 degrees into radians. Now here you come and say 360 degrees is equivalent to 2 pi radians. What about 45? If you cross multiply, you get 90 pi over 360. By this 1, by this 4. So it is equal to 1 over 4 pi radians. So by that we have needed to look on how we can convert them. So we can come here and look something else. So I hope guys you have understood how you can convert degrees into radians and vice versa. So you can come here and we look something called unit circle. A unit circle. What is unit circle? The unit circle is a circle that is centered at the origin and always has a radius of 1. The unit circle will be helpful to us when we define the trigonometric ratios. So, a unit circle, we have known that it is a circle that has an origin and it has that is a diameter, a radius of 1. So we can consider this one here. So it has an origin here at the center. It has this. We are given as 1. Still this is 1, this 1, this 1. So here we can consider now. This is this is our radius, which we are given as 1. Now we can take this as, we can get x and this is p. Now what if we take this as the right angle triangle? How can we go about this? So we can look about trigonometric function definitions. So here we know that a right angle triangle can be formed from an initial side x, r and p. So where r is the radius and hypotenuse of the right angle triangle. Now our r is the hypotenuse and at the same time is the radius of the circle. So Pythagoras theorem tells that you can, as you all know, that x squared plus y squared is equals to r squared. And you still therefore you can come, if you want to find r, you can take r is equals to square root of x squared plus y squared. And still, you know, the 6 trigonometric functions can be used to find the ratio of the length. You know, you can find SOHCAHTOA. SOHCAHTOA, it means that sine, we can call this theta. Sine theta is equals to opposite over hypotenuse. And cos theta is equals to hypotenuse, adjacent over hypotenuse. And we have tan theta is equals to opposite over adjacent. And still we have something called cosec. Cosec. That is it is cosec, which is denoted as CSC theta is equals to 1 over sine theta, which is now the reciprocal of this. It is hypotenuse over opposite. And still we have something else called sec. Sec theta, it is now 1 over cos theta, which it is the reciprocal of this hypotenuse over adjacent. And we have the last one, cot. Cot theta is 1 over tan theta, which it is Now reciprocal of this, which it is adjacent over opposite. Now by that, these are the 6 trigonometric functions. Having known all these, we can be in a position to find all the sides and still find the angles here and here. Since we know this, we can make to find this and this we can call it as alpha. So we can look something else still under the unit circle, so that we can see how we can solve all the problems. So let's take for example, we are told find the trigonometric ratios of the angle. Find the trigonometric ratios in the triangle, ratios of angle theta. And here we are given a triangle. Now this is we are given this is like this, and we are given this as our theta. Our theta, which now we are given this is a straight line, but this is a right angled triangle. This is 12. We are given this as 5. Now the first thing we need first to find the length. This length, we can call this A, we can call it capital A, capital B, and capital C. Now, AC squared is AB squared plus BC squared. So, AC squared is equals to, now, it is 5 squared plus 12 squared, which it is 25 plus 144, which it is 144 plus 25, 144 plus 25. Ensure that you are not using your mind if you know that you are not that accurate. This is 169. So our AC is equal to square root of 169, which it is 13. Now we have gotten this as 13. And since we are told to find all the now here it is all the trigonometric ratios. Now we can come here and start with SOHCAHTOA. These are the first 3. So sine theta is equals to, sine theta it is opposite over hypotenuse. As we had seen here, it is opposite over hypotenuse. Now this is opposite over hypotenuse. So it is 12 over 13. Since this is the opposite and this is the hypotenuse, so we can take 12 divided by 13. 12 divided by 13. So 12 divided by 13, we have 0 point is equals to 0.92308 or 31. So theta will be sine inverse of 0.9231. So this is, now you press shift and then the sign of the answer which you had gotten. Now here we are getting theta is equals to 67.38 degrees. You can give it into 2 decimal places. Now we can call this one. So our 2 here is cos theta, which is adjacent over hypotenuse. In this case, this is our hypotenuse. This is our opposite, since we are considering theta, and this is our adjacent. So we need, it is adjacent over hypotenuse. So it is 5 divided by 13, which is 5 divided by 13, which is 0.3846. Now theta will be cos inverse of 0.3846. Now here you can take shift cos of answer, which we are getting 67.38 degrees. You must put the answer that you are going to get here is the same as the one you are going to get here, and still is the same as the one you are going to find here for number 3. Tan theta is equals to Now tan, it is opposite over adjacent. It is opposite, which it is 12 over adjacent is 5. So 12 divided by 5, it is 2.4. Now our theta will be tan inverse of 2.4. You press shift tan of answer. Now this is 67.38 degrees. This is our theta. Now, as you can see that this is equal to this and this is equal to this. So the moment if you are given a certain question to do with trigonometry and this is a right angle triangle, you can find all the three sides and then you use any of these, any one of them. There's no need of you doing all the three. Now you can come here and still continue with this. Now we are told to find all the six trigonometric ratios. So there is still, we are remaining with something to do with cosec. Cosec theta is equal to 1 over sine theta, which it is hypotenuse. We can see 1 over sine. Let's see 1 over sine. We had gotten as 67 sin theta, our 67.38. So it is 1 divided by sine 67.38. We are getting as 1.08. So I think all the three trigonometric ratios we have gotten there. Let's see if you want to use the other. It is, now we are told it is hypotenuse over, this is hypotenuse over opposite. So it is 13 divided by 12 is equal to 13 divided by 12. You see, we are getting 1.08, which we have gotten here if we had taken direct 1 over sine. Since there is, if you can recall, cosec theta, we had said it is 1 over sine theta, which it is hypotenuse. Since we are taking the reciprocal, hypotenuse over opposite. Since we are taking the reciprocal of sine theta, and sine theta we had seen it is opposite over hypotenuse. Now that is how we can see, and we can make it to see that this and this is the same. Now we need to find the other two of them, because we need to find sec theta. Sec theta, we had seen that sec theta it is 1 over cos. Now from here Socrates, it is the second cos theta. It is 1 divided by, now we had seen cos 67.38 degrees. We can take cos 67.38, then 1 divided by answer. Here we are getting as 2.59. So this is 2.60. Now we want to see sec theta also can be found as reciprocal of cos theta. It is hypotenuse over adjacent, which it is, our hypotenuse in this case is 13 over adjacent is 5. So we can take 13 divided by 5. We are getting exactly 2.60. Now we want to find the last trigonometric ratio, which it is cot. Cot, it is the you can take 1 over, that is the reciprocal of tan. So we want to see for the tan here is, we can see that for the tan, okay, not tan, it is cot. Cot theta, it is 1 over tan theta. It is 1 over, we had gotten that 1 over tan 67.38, which it is equal to, we can take tan 67.38, then 1 divided by answer, we are getting as 0.4167. Now we can still take cos theta, we had given as 1 over tan theta, and it is the tan theta, which it is considering the Socrates. we have tan is opposite over adjacent. Then this will be adjacent over hypotenuse. Now in this case, our adjacent is 5 over 13, which is equivalent to 5 divided by 13, it is 0.38, 0.3846. If you can take tan, let's see, tan 67.38, then 1 divided by answer, it is 0. So this is approximately equal to this. So we can still look something about something else, or we can make it to use or to find something else to do with still trigonometric ratios. Let's see. So by that we have seen everything, and we have made it to work out and seen how things can, these things you can, now I think up to here you can be in a position to find all the trigonometric ratios. Now we want to use the, okay, we can see another example. This is example 2 on how to find trigonometric ratios. We are given a right angled triangle here like this, and this is 6, and this is theta, and this is 8. We can call this A, B, C. Now, the first thing is to find the hypotenuse. In this case, since we are considering this angle, this is the opposite, this is the hypotenuse, and this is adjacent. So we can come here and say AC squared is equals to, now AC squared is equals to now this. I don't know whether you are understanding it. It is now, it will be AB plus BC, all this squared. Now, if you are told to find BC, now you can make BC the formula of the subject. Now it will be AC squared, we can take this on this side, minus AB squared is equals to BC squared. If you are told to find AB, we can take AB is equals to, we can take this on this side. It is AC squared, okay, this is squared, minus, now this is BC. Now I hope you are understanding here and you have seen how the reason why we are using this. Now, but in this case we are interested with this. Now we want to find our hypotenuse. Now our AC squared is equals to AB. AB is 8 squared plus 6 squared is equals to, this is 64 plus 36. So this is AC squared. So AC is equals to square root of answer. 64 plus this is 100. So our AC is equals to 10. Now this is 10. Now we need to find all the trigonometric ratios. We start with the simplest one. It is SOHCAHTOA. SOHCAHTOA. So SOHCAHTOA here we can see. SOHCAHTOA, it is sine is equals to opposite over hypotenuse. Then cos. So our sine theta is equals to opposite over hypotenuse. This is opposite over hypotenuse. It is 8 over 10, which it is, you can take 8. You can calculate 8 divided by 10, which is 0.8. So our theta is equal to sine inverse of 0.8. You can take shift sine of answer, it is 53.13 degrees. Now this is our theta. Now we want to find cos theta. Cos theta in this case, we are told it is adjacent over hypotenuse. So it is adjacent over hypotenuse. It is 6 over 10. It is, which is 6 divided by 10. It is 0.6. So our cos theta, okay, this is theta, is equals to cos inverse of 0.6. So our theta will be, so shift cos of answer, it will be 53.13 degrees. So you need to find tan. Tan theta is equals to, it is opposite of adjacent, which opposite is 8, adjacent is 6. It is 8 over 6. So is equals to, you can take 8 divided by 6. It is 1.333 recurring. So tan, okay, it is theta is equals to tan inverse of 1.333. So take shift tan of answer, it is 53.13 degrees. Now here we have seen that all these are equal. So you can, given triangle, this of right angle triangle, you can find the ungiven or the unknown value, and then you solve within any of these. Now we want to find the rest. That is cot, cosec, and that is all those, the three of them. There's cosec, tan, and cot. We can see how we can make use of all these. So we have seen there is three other as we had seen here back. The other three ones is cosec. There is cosec. Sorry for that, my pen is drying up. So this is cot, and there is cosec and sec, and still there is sec. So this is for sine, this is for cosine, and this is for tangent. Now, having known that, we can come and solve for cosec theta is equal to 1 over sine theta, which it is 1 over, in this case our theta is 53.13, which is equal to, we can take a calculator and solve this. So it is 1 divided by 53.13. So here we are getting, okay, it is 1 over sine, sorry for that, it is sine 53.13, then 1 over answer, it is 1.25. Now we can still see that cosec theta is equal to 1 over sine theta, which it is hypotenuse over opposite. In this case, our hypotenuse is 10 over 8. So it is 10 divided by 8. It is 1.25. These and these are equal. Now we can come and see sec theta is equal to 1 over cos theta, which is equal to, we can come here, it is 1 over cos 53.13, which is equal to, we can take cos 53.13, then 1 over answer. Here we are getting 1.667. But still we can come and say that our sec is equal to 1 over cos theta, which it is now the inverse of that is the, we can take reciprocal of cos theta, which it is hypotenuse over adjacent, which is equal, our hypotenuse we are given as 10, our adjacent as 6. So you can take 10 divided by 6, which it is still giving 1.667. Now we can come and find that one. Sec, okay, not sec. We have looked for sec. It is cot theta is equals to cot theta. It is inverse 1 over tan theta, which it is 1 over tan 53.13, which is, we can take tan 53.13, then 1 over answer. We are getting 0.75. Then we can come cot theta is given 1 over tan theta. In this case, it is adjacent over opposite. Our adjacent is 6, our opposite is 8. So 6 divided by 8 is equal to 0.75. So by that, you can see that we can make it to solve all the 6 trigonometric functions. That is, there is all the, let's write again, all the 6 trigonometric functions are like as shown. Let's see. So, there is sine theta, cos theta, and there is tan theta, and there is cosec theta, and there is sec theta, and this is theta, and this is theta, and there is cot theta. In this case, tan theta is equals to 1 over, not tan theta, it is cos theta, cosec theta is equal to 1 over sine theta, is equals to 1, now sec theta is equal to 1 over cos theta, and cot theta is equal to 1 over tan theta. For this, you can use SOHCAHTOA, where you can simply come and see sin theta is opposite of hypotenuse, cos theta is adjacent of hypotenuse, and tan theta is opposite of adjacent. Now by that we are in the position to fight, and we have found all the trigonometric functions, and we can see another thing here called find the value of trigonometric functions that we have seen. So we can look another subtopic here, which is called the order pair, that is with, okay, let's see, finding the missing side length of the angle. Let's see. Let's first clean the board. So here, this subtopic is find a missing side length given an angle measure. Given an angle. Now this is it. Now here, if you are given an angle, you can make it to solve all the sides and still be in a position to find all the other things that will be told. How? Let's look an example. We are given a triangle here, a right angled triangle. We are given here, our theta is 30 degrees, and we are given 5x and y. We are told 5x and y. How can we go about this? Now we can use concept of SOHCAHTOA. And since here this is the angle that we are considering, then this is opposite. We can say this ABC. Opposite. Here we can come and say opposite, and this is adjacent, and this is hypotenuse. The longest side is the hypotenuse. Now from here we can see that, remember, we are given our hypotenuse as 5. So we can use sin theta in this is equal to opposite over hypotenuse. In this case, we are given opposite and sin theta. So sin theta, now theta is 30, sin 30 degrees is equal to opposite, we are given as x, over hypotenuse we are given as 5. Now here we need to find x. X is equal to, you can come and find, that is sin that 5 sin 30 degrees. Now sin 30 is a half. So x will be 5 times 0.5. It is 2.5 centimeters. Now that we have found, now we can come and say that AB squared is equal to, now we need to find now BC. From now this is the longest side, now it is AC squared is equal to AB squared plus BC squared. But we need to find BC. Now we can take this on this side. So AC squared is equal to, minus AB squared is equal to BC squared. But here AC we are given as 5 squared plus our AB is x, which we have gotten now this as 2.5 squared is equal to AB squared. Now we can take 5 squared is 25, 2.5 squared is 15.645 is equal to AB squared. Now plus 25, we have 40.625 is equal to AB squared. Now we can take square root on both sides. Now this will cancel with this. Now our AB will be square root of 40.625, which is square root of this. Square root of answer, which is 6.5. 37 centimeters. Now we can come here and look at another example. So we are going to find the value of x. This is x, given that this is 52 degrees, and here we are given that this is 16. Now since we are still considering this angle, this is our opposite, and this is our hypotenuse, this is our adjacent. Now we can use the concept of SOHCAHTOA. This is now sine theta is equal to opposite over hypotenuse. So our sine, in this case our theta is 52 degrees, is equal to opposite, we are given as 16 over hypotenuse. So we need here to find hypotenuse. Now our hypotenuse will be 16 over sine 52 degrees. Now here you can take sine 52 degrees, sine 52, which is now our hypotenuse is equal to 16 divided by answer, which is 20.3. And now we need to find x still. So x, now we can A, B, C. For you to find x, you can use, now this is adjacent over opposite, which is adjacent over, there is no something like that, so you can use opposite over adjacent. So you can come opposite over adjacent is tan 52 is equal to opposite is 16 over now x. So our x will be 16 divided by tan 52. So our x, which is equal to, so tan 52, then 16 divided by answer, it is 12.5. But still, you can come and use this other one here. You can come and use that AB. Okay, we are going to find BC. Now our AC squared is equal to AB plus AB squared plus BC squared, which in this case we need to find our BC. Now our BC squared is equal to AC squared minus AB squared, which is our AC is 16. Our AC, we had found our AC somewhere. Our AC, our hypotenuse, we had found our it's 20.3 squared minus our AB is 16 squared. Now 20.3 squared minus 16 squared. Now here you get 150. Here we get 156.09 is equal to 156.09. Now we need BC squared. Our BC is square root of 156.09. Let's take square root of answer. We are getting exactly 12.49. If you round off, it is 0.5, which it is this that we had gotten here. Now it's upon you to solve and to check and know the simple method that you are going to use. Now from there, we can still find, if now we have considered a lot this. If you are given an angle here, you can still find an angle, this angle here, and still you can still find, now this given, this is 90. And remember, this works only when we are given the right angle triangle. That is the time we use this. So we are still going to fight all the other methods that you can use to find angles and the sides of a triangle. If it happens that you are given a triangle which is not right angled triangle, that is, if you are given a certain triangle here and given this, that this is 6, 8, 10. How can you make to find these angles here? And how, if you are not given this, how you can make it to find this, given this is x. But here, I may give you some fundamental identities that may be important to you, that can help you in solving all these trigonometric ratios. Now, the first thing you need to know is that sine theta, as we had seen, sine theta is equal to reciprocal of 1 over cosec theta, which is simply, it shows that cosec theta is equal to 1 over sine theta. And then cos theta is equal to 1 over sec theta. Then sec theta is equal to 1 over cos theta. Now still there is tan theta is equal to 1 over cot theta, which cot theta is equal to 1 over tan theta. So by that you can make it to solve all the equations. There is still quotient identities. So quotient identities, and for now I think we are going to stop there. We are going to look for how we can find identities, how we can use identities to find exact values. Still we can find the sum difference for the sines and cosines, and find double angle formula, how you can use double angle formula. And still we look at product to sum functions, and still we use law of sine and still law of cosine. That is how you can use this, you can solve this triangle given an right angle triangle, that is triangle that do not have right angled angle, that is 90 angle. We still find how we can find the exact values of expression, how we can make it to find the range, maybe AB, which is x. So we find the value of x, and by that we'll be able to have done away with trigonometry 1, and still we'll be in a position to look for our trigonometry 2. So thank you very much for being with me, and I may wish to give you my number, so that if you have any inquiry and you may want to tell me something, my number is 0703 858 477. You can send a message on WhatsApp, or you can call me and tell me if there is a mistake that I have done through teaching, because we are all human beings, or if you have any question or any suggestion on certain topic that you want me to cover. Since we are starting off, and I know that we are going far and we are going to help each other all through this journey. So thank you very much. My name is Frederick Nganga Waidera. I'm a student teacher at Masai Mara University, and please like my YouTube channel, all the videos, subscribe and share. Please let other people know that we are doing this together and that we are going far. So thank you very much, and God bless you.